Hello everyone. Today, I will provide information about the topic of different diaphragm failures in the STA program. How are different diaphragms assigned in the STA program? And in which situations do we need to apply different diaphragms? I will provide information on these topics. The assignment of different diaphragms is definitely a method that must be applied in structures like the one I have shown here. If we examine how this example response differs from normal structures, it is evident that we have a structure where the foundation and basement are rigid. The foundation and basement behave like a single structure. However, it can be seen that different structures are rising above this basement and foundation, with separate blocks being constructed. If we are solving these structures within the same data, we must perform different diaphragm jumps for these blocks that rise separately. Because if we solve these structures under a single seismic effect, we will be considering the highest period, and will have also solved the other blocks under lower seismic effects. This will not be a correct approach either, because the rigidity of each block is different from one another. Their heights may also vary for this reason. They will behave more rigidly. Blocks at a lower height will actually bear more seismic load. However, if we consider only a single earthquake effect under the largest period, and apply the same earthquake to the entire structure directly, we will have designed the structure under low seismic loads, and the peak seismic effects we calculated for the whipping effect will also be incorrect. Therefore, when we apply different diaphragm effects, each block will be calculated under its own seismic effects, and we will achieve a much more accurate result. Of course, you can also solve these blocks within separate data sets. In that case, there is no need for different diaphragm assignments. When you solve these blocks in separate datasets, it will receive the seismic effects according to its own rigidity, and will provide you with the correct result again. For example, let's say that this block experiences a seismic effect of 10 tons at the top. On the other block, let's assume it experiences 5 tons. When you solve them separately, you will see the values of 10 tons and 5 tons here. However, when you solve them together, you will see the total, which is 15 tons. In other words, there will be no issue, as long as you assign different states between the calculations. Different diaphragm assignments are not only used in these types of structures. Different diaphragm assignments also need to be applied in structures with expansion joints. This is because, in those cases, you are separating the related structures with expansion. Now they exhibit different behaviors from each other. They should also undergo different diaphragm assignments in the same manner. Here, we mentioned that accurately calculating seismic loads is very important. So why are seismic loads calculated incorrectly when we do not implement different diaphragm failures? I will also mention this. In fact, when you perform a model analysis solution, the seismic loads are calculated correctly even if you do not apply different diaphragm assignments. However, if you do not perform different diaphragm assignments, even if the modal analysis is calculated correctly, we are required to compare the seismic value obtained from the modal analysis with the value obtained from the equivalent method multiplied by the beta irregularity factor. We need to consider the larger of the two as the total seismic effect. If beta is an irregular structure, 0.9 is used. If it is a regular structure, 0.8 is used. The value is entered. It is entered from here. And let's say that since we provided a total seismic load of 0.9 in the equivalent earthquake, the program will also multiply by 0.9 and compare it with the value obtained from modern analysis. It will take the larger of the two. If the modern analysis is large, there will be no problem. However, there is a possibility that the equivalent earthquake may be significant. In terms of accurately calculating the equivalent earthquake load, we need to perform different value assessments and ensure that each block calculates within itself. Otherwise, it will go with the highest period condition and solve the entire structure, resulting in an incorrect seismic calculation. The value we obtain from the equivalent will be incorrect. If the equivalent is large, we will have designed our structure with an incorrect seismic force. This is important from this perspective in multi-block structures. We have an option related to the seismic calculation. Here, we need to mark this. Yes, look here. We are coming to the seismic code. Option, that is, the earthquake options. Here we have the option for seismic analysis. When we get to this point, yes, we need to select this option. For multi-block structures, it is important for this to be selected. When we select this, as can be seen from the shape, each block performs a solution here according to its own period, its own rigidity, and under its own seismic loads. Here, you can see the option that should be selected for single block structures. It performs the solution based on the structure with the largest relevant period. It is designed as a single block structure, and the seismic load affects it accordingly, distributing the seismic loads to all blocks based on this. As can be seen, each block does not distribute seismic loads within itself if it is a single block structure like this, or if separate blocks connect at the upper floors. You can choose this method. However, the option you need to apply here must be this one. We are selecting this option. After selecting this option, we come here. Now, how will the different diaphragm assignment be done? I will show this here. Of course, in structures separated by expansion joints, the separation of blocks in the upper floors is a reasonably expected behavior. However, in very rigid structures like basements and foundations, the separation due to expansion joints can cause significant damage to the building. And this practice is not recommended by regulations. For this reason, please be careful not to make any separation with expansion joints in your basement structures. Foundation. As already seen here, there is a single rigid structure in the first two floors. Starting from the third floor, different blocks begin to emerge and continue up to the 8th floor. Now we return to the options section for different diaphragm assignments. And here, in the options section, now we come to the analysis options. Initially, we are on page 1 of the static analysis options. The different diaphragm assignment option is here, and we need to select this option. After selecting this option, we come to the floor arrangement button. Here, immediately, the diaphragm select button appears in front of us. Here, when we click the diaphragm selection button, the first diaphragm appears. We have the opportunity to assign a different R value for each diaphragm. Because we will assign different diaphragms to the blocks, the structure of each block may be different. The behavior of the structure. Therefore, we can enter this R value separately for each block. Since our first floor and the first two floors are completely rigid, we can also perform a single diaphragm assignment. There is no issue here. To perform the diaphragm assignment, I select the column with the mouse and include it within the frame. Yes, it has now completely assigned the diaphragm to the first floor. Then I come to the second floor. Look, there is also an automatic diaphragm assignment option here. I am selecting the automatic diaphragm assignment option. When I click on a floor, that's enough. It will automatically detect it. Look, it has completely assigned the diaphragm for the relevant floor by itself. If you want to delete the diaphragm assignments you have made, then by clicking on the new diaphragm option with this selection, all your diaphragm assignments will be deleted and you will have the chance to reassign the diaphragms. Here we have reached the third floor. From this point on, we need to make a different diaphragm assignment. Of course, we can assign our first block with diaphragm 1 again. The rigid diaphragms, that is, the rigid blocks, can have the same diaphragm number as mentioned earlier. This is not important. We assigned it this way. However, we need to assign this as D2 now I'm coming here, and selecting this as D2. Afterwards, I select it as D3. Then I assign all the blocks separately in this way. D4, D5, D6. As can be seen, I can enter a separate R value for each of them. There is no issue here. I can enter the appropriate R value for all of them here. D8 and D9 should be noted as they take into account all elements. It is beneficial for us to check Yes, as you can see, I have currently performed diaphragm assignment for 12 of them. However, we have only done this for the third floor, of course. We can apply it to all floors for faster processing. Now, when the option for yes for all floors comes up, we can see the three-dimensional shape here, which shows the areas assigned as yes. Now, when I select this area again, you can see that the first one has been completely assigned as 1. Then, I move on to the second section, where the option for all floors is also selected. When I selected it this way, it assigned it here as well. Of course, when we do it this way, it assigns quickly, but different diaphragms started to form again on the first 2 floors. After that, you can assign them to a single diaphragm again, from scratch. This situation occurred because there are completely rigid structures below. In fact, the most logical approach here was to start assigning from the 8th floor. From there, you would directly select and assign all the floors. However, separate diaphragms would still be assigned for the first 2 floors. Then you came back and could not assign the diaphragms on the first 2 floors as a single diaphragm again. Of course, you will need to turn off option 10 here. It was again taken completely as D1 here. Yes, look. On the 3rd floor and the 4th floor, it has already taken D1 on all floors. When we look at D2, we can see that it has also been taken on all floors. Here. For example, let's look at the 2nd floor. A similar situation has occurred on the 2nd floor as well. Now I'm taking it as D1, like this, yes. However, when we look at the 3rd floor, there is no issue with D1 and D2. Similarly, you will assign all of them, collectively using the option for D3 and D4. Finally, you can come back to the first 2 floors and complete the assignment by selecting D1. Now, I will quickly finish these steps and continue with the video. Yes, our allocation is now complete. After making the allocation, you select the option here again to view the relevant diaphragms in 3 dimensions across all layers, meaning their distribution. For example, the D1 diaphragm. Yes, in this way, we can see that it has taken the entire rigid structure and the first block here. Then we come to D2. Yes, we can see that this is just the 2nd block without touching the rigid part at all. Then the 3rd block, this way. We can visualize that we have made a correct allocation. Yes, we can visualize all the blocks when we arrive this way. Yes, we have completed 12 allocations at this point. After this, when we analyze the structure, there may be different our evaluations for the blocks, since calculations will be made separately. As you know, when you do not meet the shear base moment ratios, it asks us to reduce by 4/5. For example, this block may meet the requirements while this block may not. In that case, the program will suggest this to us, asking to reduce it by 4/5. So, you can adjust R for just this block while keeping the others unchanged, taking the other one to 4/5 times. If such a situation arises, it will already present itself in the analysis results. In this way, we have made different diaphragm allocations. Of course, now that we have assigned a separate diaphragm to each block, when we open the rigidity centers, we will be able to display a separate rigidity and center of gravity for each block. Here, since there is only a single block, we see only one rigidity and center of gravity. However, as you can see, when we move to the 3rd floor, you can display a separate rigidity and center of gravity for each block. This also shows us that we have made a correct diaphragm allocation for the 4th floor. Yes, in this state, our structure has now had the diaphragm allocation completed. A is ready for analysis. There is one more situation I would like to mention here. As seen here, we have 2 common blocks at the bottom. We have two basements. The contribution of the lower blocks to the work blocks is calculated by distributing it in proportion to the weights of the lower blocks and is allocated to the blocks accordingly. In this way, we have also completed our diaphragm allocation. Now, we can save our structure and perform the analysis. Yes, our analysis has concluded we did not receive any warnings related to any error coefficient here. So, all diaphragms are currently assigned as R7, and we are proceeding this way. When we enter the earthquake report section here, yes, here it shows the separated diaphragms. And when we go down a bit, we will now come to the earthquake loads. Let's come from here. Yes, there are earthquake loadings at the level of the floors. When we look at the total values in the end, in earthquake loading, here it shows the blocks individually. At the top, it displays the total loading. Now, the total values obtained under modal analysis and HDR earthquake loading will be the same as the sum of the values obtained for the blocks when you solve the blocks separately. If you solve all the blocks separately, the total earthquake loadings will be the same as the effects here. Similarly, the total peak effects, when solved separately, will provide the peak effects here at the beginning when the first block and the second block are combined. In other words, it will yield a value of 47.52. If you solve with separate data, you will get these as well. Here, of course, each block is calculated internally as we mentioned. For this reason, as can be seen here, there are separate calculations for each of them. Yes, these are mine. Different thoughts related to mathematics. I thank you very much for listening to me. I wish everyone good work.